Okay, so welcome to the last video on area of a polar curve. In this video, we're going to look at the area of an inner loop and then look at also another problem where it's shared area, because that seems to be the most difficult. All right, so the inner loop, we know that this has an inner loop because A over B is less than 1. So we have 2 over 4, which is 1/2 is less than 1. So that produces that inner loop. So what we're going to do is we're going to set this equal to 0, and we get 4 cosine theta, excuse me, is equal to -2. So then cosine theta is equal to -1/2, and we know that that happens at 5 pi over 6 and 7 pi over 6. Okay, so now that doesn't seem to make sense because 5 pi over 6 is in the second quadrant and 7 pi over 6 is in the fourth quadrant. But we have to look at it as if those radial lines are extended, remembering how we can graph a polar curve. Where are my lines again? I keep losing my lines. Right there? Okay, so what that's telling me, 5 pi over 6 is actually like here. And 7 pi over 6 is actually here, because they extend. So to find that area of the inner loop, I can actually integrate from 5 pi over 6 to 7 pi over 6. I'm not going to get a complete answer because I don't have my calculator with me, but the area formula would be the area is equal to 1/2 the integral from 5 pi over 6 to 7 pi over 6, and it would be r squared. So 2 plus 4 cosine theta quantity squared. And you can take your handy-dandy calculator and figure that out. And that is on your quiz tomorrow, so make sure you can do that. Last problem, we're going to look at the area shared by r equals 2 cosine theta and r is equal to 2 sine theta. So looking at this, we can see that our radial lines, or our point of intersection, is here. So we can do this a couple of different ways. I'm going to do it with 2 integrals, but you could actually find 1 and multiply by 2. But what I'm going to do, again, we're going to set these two equal to each other, and we get 2 cosine theta is equal to 2 sine theta. Ooh, I just forgot the whole sine thing. So that gives us cosine theta is equal to sine theta, and we know that happens at pi over 4, and it also happens in the third quadrant, but that isn't significant for what we're doing because our intersection is in the first quadrant. So when I take that first area, when I go from 0 to pi over 4, and one of the reasons I'm going from 0 to pi over 4 because it's in the first quadrant. So going from 0 to pi over 4, I'm being defined by, I need smaller lines. From 0 to pi over 4, I'm only being defined by this part of the graph. Okay? So when I go from 0 to pi over 4, I am only being defined by this blue graph. Okay? So I go from 0 to pi over 4, and the blue graph is symmetrical to the y-axis, so I know it's sine. Now, above the radial line, above that line of intersection, now that area is defined by the red circle. So that's this guy here. Oh, should use a different color. That's this blue guy here. He is actually defining this from pi over 4, and it's being defined by that red curve. Well, where kids had trouble today is determining where am I going to. Because I'm only in the first quadrant, I'm going to pi over 2. So this one would go from 1/2 pi over 4 to pi over 2. And it's being defined by the red graph, which is cosine. So this would give me 2 cosine theta quantity squared. And then after this, of course, I just use my calculator to determine that area. And I think I did this problem in class today, so that area is maybe something. It's an answer. I promise it's an answer. And I just don't have it in front of me right now. But you can use your calculator to figure that out. Okay? So that's it for the last video. So what you should be able to do right now is find the area of just a polar curve, if it's just one curve, the area inside one, outside the other, the area shared by a polar curve, and you should also be able to find the area of an inner loop. So that's all I got for you, folks, and that's it for Calculus BC. You have successfully completed Calculus BC. Give yourself a pat on the back. Have an amazing day.